Hello, welcome to Zigmatech Learning Hub. I will be your instructor for chemistry. For this class, we are going to be taking our exercises from the ExamGuide app. If you don't have the application already installed on your device or on your phone, I will want you to download the app in order to follow along in this class. ExamGuide is a leading educational app that helps students prepare adequately for various exams like UTME, Post-UTME, WEAC, GCE, KCPE, IJMB, JUPEB, Calbepedia, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. Today we are going to talk about separation techniques. Separation techniques. Now, by the end of this lesson, you will know the methods used in the separation of mixtures. The separation of mixtures. Now, what is separation technique? We've been talking about mixtures. We're talking about mixtures, and we said a mixture is a substance that can be separated. Okay? We said any substance that can be separated is a mixture. Now, what is separation technique? That method is a technique used for separation of mixtures. Now, separation technique is the method used in separating mixtures. Separation technique is the method used in separating mixtures. That technique you use, that pattern you use in separating mixtures, either homogeneous or heterogeneous mixtures, is called separation techniques. Now, let us know the methods of separation. Let us know the techniques we have in separation. Number one, we have sieving. Number two, we have decantation. Number three, we have filtration. Four, we have magnetic separation. Number five is distillation. Number six is precipitation. Number seven is crystallization. Number eight, evaporation. Number nine, chromatography. Number 10, fractional distillation. 11, sublimation. 12 is flotation. 13 is centrifugation. And 14 is fractional distillation. These are the 14 ways we can use, or 14 methods, or 14 patterns you can use in the separation of mixtures. Now let's see number one. Number one said sieving. Sieving is a technique used in the separation of two solid particles with different sizes. Now, if you look at your screen, it's doing so. Now let us know the particles, how we can separate this thing. Now I want to use beans. Now, beans. Okay, we are going to mix beans and garri. Okay, we are going to mix beans and garri so that we'll see how these particles are being separated. Now, it said separation of two. The garri is a different size from the beans. Okay, the garri is bigger. The beans is bigger than the garri. Now, as you're heating it, you're seeing the garri is going out. You're separating the garri from the beans based on sieving. As you're doing it, it is going to go out. Now, the garri will be inside this container and the beans will be inside the sieve. This thing you see is not called shifter. It is called a sieve. When you want to talk, you talk like a chemist, okay? It's called a sieve. As I'm doing it now, you're seeing the garri going down. You're seeing the garri going down. Now, I have separated the garri and the beans, as you can see. I've separated the garri and the beans. Now, the process of you separating this garri and beans using a sieve, because of its different size, is called sieving. It's called sieving. So in essence, the solid particles of different sizes can be separated by sieving. As you can see already, the garri is inside here and the beans is here. I've separated it. Instead of you stressing yourself, picking the beans one after the other. So separation technique makes you save time when you want to separate mixtures. Now, the second one is decantation. Decantation is a method used in separating liquids from solids. and other immiscible liquids. Immiscible liquids are liquids that cannot mix. Immiscible liquids are liquids that cannot mix. Example, diesel and water. Okay, in your house, diesel and water. These things cannot mix together. They can't. So in essence, decantation is the best process to separate this thing. But first of all, decantation is not an accurate way of separation. It is the only separation technique that is not accurate. I will tell you now. We'll do the experiment now and you'll see it. Now, I'm going to use sand and water as you saw in your screen. I'm going to use sand and water. Now, as you can see, I'm using sand and water. Now, me mixing the sand and water together, they will not mix. Okay? As you can see, this is the sand and the water. So there is a demarcation between the sand and the water. Look at the sand very well. The sand is down and the water is up. The same thing as the diesel. The diesel will be up and the water will be down. Why? Because the diesel, the water is more dense than the diesel. Now, why is this separation? Why is it that this separation was made? It's because the sand is more dense than the water. The sand has more mass and volume than the water. Okay? The sand has more weight than the water. And that is why the sand went down and the water is up. Now, this sand that is down, any substance, okay, in any substance in a solution, this solution is called a heterogeneous solution, as we talked about, because there's a demarcation between the two substances. Now, any substance, any heterogeneous solution, the substance that is down is called the sediment. Substance that is down is called the sediment, and the one that is up is called the supermat. It's called the supermat. So in essence, the sediment will go down as the base of sedimentation, and the supermat will be up. It said it's the liquid from solid. The supermat will be up. Now, this is, we want to separate this thing by decantation. Now, as you can see, the water is up and the sand is down. Now, we want to separate it. As I'm removing the water, I'm moving the water. Now, finish removing the water now. It's only the sand that's remaining. This is something you normally do in the house, but you do not know that you're practicing separation techniques. Most times you do not know that you're practicing chemistry in the house. There are so many things to do that you don't know what you're doing. Now, if you look at the sand, that it is still damp. It is still water. There's still water in the sand. That's why I said decantation is not an accurate way of separation, but it's still a separation technique. Now, as you can see, the water has gone out from the glass, but the sand is still wet. It still contains water. But the little amount of the water has gone out. It's the same thing when you want to sip your gari. Okay, when you put the gari in the bowl and you remove the water, the gari still has this water in it. So, but you can separate it. You can separate this particular water from the gari, a large amount of water from the gari. So like I said, remember, the particles down in a heterogeneous mixture is called a sediment, while the particle up is called the supermat. It's called the supermat. Now, the next one is filtration. Filtration is the technique used to separate undissolved solid from liquids. Now, when you say undissolved solid from liquids, if a solution contains an undissolved solid, it is called a saturated solution. Any solution that contains an undissolved solid is called a saturated solution. But the one that contains a dissolved solid is called a saturated solution. In essence, filtration is used in the separation of saturated solutions. Filtration is used in the separation of saturated solutions. And saturated solutions are solutions that has undissolved solid in a liquid. A solution that has undissolved solid. Now let us know how we are going to do this simple filtration. Okay? Let us know we are going to do this simple filtration. Now, this filtration, I will still use sand and water again. I'll still use this sand and water. Now, I am pouring the sand back inside the water. I am pouring the sand back inside the water. Okay? I want to pour the sand back inside the water. Now we are going to filter. Do it in the basis of filtration. Now, as you can see, the sand is inside the water. Okay, look at the sand is inside the water. Now, if you look at the sand did not dissolve in the water. Unlike the salt solid, the sand did not dissolve. There is still a demarcation between the sand and water. So now, separating it, I will use this as a filter paper. This is the filter paper. Now, as I pour, you're seeing that the water is going inside. The water is going inside the container. As you can see, the water is going inside the container. Now, when the water finishes, the sand will remain in the filter, in the filter paper. As you can see, the sand will remain in the filter paper. In essence, I've separated the sand and water through the process of filtration. Look at the sand. The sand now is inside the filter paper. As you can see, the sand is inside the filter paper. So I have separated this thing from the water. Why? Because this solution is a non-saturated solution. The solution is not saturated because the solid, which is the sand, did not dissolve in the liquid, which is water. So this filtration is used, like I said, in the separation of a non-saturated solution. Like I said, because the solid did not dissolve, so it is a non-saturated solution. Take note. Now, the next one is magnetic separation. Magnetic separation is the process of separating components of mixtures by using magnet to attract magnetic materials from the non-magnetic materials. Now, let me use these beans again. Okay? Now, you had let me use these beans again. And let's say office pins. Okay? I'm using beans and office pin. Now, instead of you stressing yourself in picking the beans one after the other by making mistakes, you just carry a magnet and start passing through. You see how the magnet is magneting these pins. I've magneted the pins and I've dropped it here. I've removed the pins. I've magneted the pins. It will still magnet the pin out. Now what will remain is only the beans. If you look on your table, you see that only the beans is remaining. I have finished magneting every pin inside the beans. Look at the magnet, look at the pins, and look at the beans. So I've separated the magnet from the beans. So this pattern is called magnetic separation. Okay? The beans now have been separated. Look at the beans in my hand. There's nothing inside anymore. So these are some of the processes or some of the methods we use in separation. Now the next one is distillation. Distillation is the physical separation of miscible liquids based on their different boiling point. Miscible liquids are liquids that can mix. Okay? Miscible liquids are liquids that can mix. Example is ethanol and water. Ethanol has a boiling point of 70 degrees centigrade, while water has a boiling point of 100 degrees centigrade. So in essence, if both of them are being mixed together, for you to separate them, it is by distillation. As you can see on your screen, the heat. It is being heated. Okay, the substances are being heated. And When it gets to 70 degrees centigrade, you see the ethanol going out into the chlorochemical flask. The ethanol is going into the chlorochemical flask based on condensation. It is going, it is evaporating, and it's going to condense into the chlorochemical flask. So in that pattern, you've separated the ethanol from the water. Now, when the ethanol goes out from that particular liquid via evaporation into the chlorochemical flask, water will remain in the container. The water will remain in the container, and the ethanol will go into the chlorochemical flask, as you can see. So it has been separated. You've separated it based on their boiling point. When it gets to 70 degrees, the ethanol will leave the water and go inside the chlorochemical flask, while the water will remain inside the container. So this thing is based on their boiling points, based on the separation of their boiling points. Two liquids that can mix, you separate them with their boiling point. Now the next one is precipitation. Precipitation is a method used to separate mixtures based on the solubility of its components. Now, solubility, okay? It is not only liquids that can be soluble. Solids too, it's not only solids that can be soluble, liquids too are soluble. Soluble liquids are like acids. They dissolve in a base to form salt and water. Now, insoluble liquids are like sugar, salt. They dissolve in a liquid of water and form a solution. So in this concept, precipitation is used to separate mixture based on solubility of its component. In essence, I can put salt and water and sugar. It will give me sugar solution. So for me to separate this particular thing, it needs to be precipitated. If you look at it, you see that the solution, the first one in your screen is the solution. The second one is the suspension. The suspension is the one that is down and the supermate is up. Now the precipitates that you've separated will be down. Why? Because the solute always become the sediment. The solutes are always the sediment, while the solvents are always the supermates. They're always the supermate, the solvent. Because when they say solute, when they say they dissolve, in essence, they are going to go down. That means they have more mass than the solvent. Okay? They are heavier than the solvent. So they are going to go down. They are going to dissolve. So basically, on this, their dissolvement, how you can separate it is by precipitation. It's by precipitation. Okay, based on their solubilities. Now, the sugar, the salt is more soluble than sugar. Salt is more soluble than sugar. Now, when you put them together, you pour all together, you mix them together. Okay, the salt always takes the day when you put sugar and salt together. Even a pinch of salt you put overcomes. In essence, the salt have more mass than the sugar. So for you to separate the sugar from the salt inside that solution, you're going to precipitate it. So in essence, the salt will be down and the sugar will first of all evaporate, or first of all separate himself from the salt. When that is done, it has been precipitated. Now the next one is crystallization. Crystallization is used to separate a solid from the mother liquor. A solid from the mother liquor. Mother liquor means what mother, it means, we know what mother is. Okay, the main person. Liquor is a liquid. We know that every liquor is a liquid. So the solid inside the mother liquor can be separated by crystallization. Crystallization is the use of, is just like the solid must be crystals. It has its shiny, it has this, the solids has, we know that solids are crystals. Okay, we have crystal solids. So this crystal solid have been separated from their mother. It is their mother that formed these crystal solids. So when you separate it, it becomes a process of crystallization. The next one is evaporation. It's a technique used in separating soluble solids from liquids. Salt and water Okay? The salt is a soluble solid. Copper 2 sulfide in a soluble water. Copper 2 sulfide has a slight blue. It's blue in nature. Okay? When it becomes a solution, when you put it in water, it becomes a solution. It dissolves completely. So the only process or way you can separate this thing is by evaporation. Put in a salt and water, put it on the pot. Put it inside the pot and put it on the fire. You see that when you're boiling, the water will evaporate and the salt will remain in the pot. The salt will remain in the pot. So that process where the water is being separated from the pot via evaporation. You remember the solid, the liquid must have to change to a gaseous state, okay, for it to evaporate. Eva means up. For it to go up, it must have to change to a gaseous state. Now, when it leaves the pot, the salt will remain in the pot. In essence, this particular salt and water has been separated via evaporation. Okay? Via evaporation. Now, chromatography. Chromatography is used for separating components of solutes in a mixture on the basis of relative amount of each solute distributed between moving fluid stream. Now, in this one, the solutes are not solids. The solutes are fluid. Okay? A fluid, I think I've defined that for you sometime. A fluid is any substance that deforms under shear stress. That shear stress there is force. So, and the subset of fluid are gas, liquid, and plasma. These are the three states of matter that can exist in a fluid. Either it will be a gas, it will be a liquid, or it will be a plasma. Now, if you check on your screen, you see that this particular one is gases and liquids forming together. Now, a film is being formed in chromatography. Okay, there's a paper called chromatograph paper. You put it inside the liquid. You put it inside the liquid. Okay, let's say you mix iodine. You mix liquids like iodine, chlorine, and iodine, chlorine. Okay, you mix them together and put it inside a container. I'm giving an example. Okay, and they mixed. One of them must have to be a solute, and one of them must have to be the solvent. Now, when you put this chromato paper inside, it will be a separation, as you can see on the screen. The iodine will take a separate range, a separate track. The chlorine will take a separate track. Every single solute in that particular solution will take separate tracks. Okay? And as they're coming out, they will be leaving the solvent. They will be leaving the solvent in their fluid state. They'll be leaving the solvent in their fluid state. Now, when this is done, it is called chromatography. It's just a simple thing. Put a chromatograph paper inside the solvent, and the solutes will just be taken their separate ways, their separate track in the paper. And they're taking their separate track in the paper. Check, you see that the films are being formed in that process. Now, the next one is fractional crystallization. It's used to separate two solids based on the difference of their solubility in the solvent. It's the same thing like I said, sugar and salt. Okay? Sugar and salt. You just have to put it, one will evaporate, one will remain in the water. Simple. When you heat it, one will evaporate. In essence, the sugar will evaporate, okay, with the water, and the salt will remain. In that process, you have separated the salt and water. You can just do a simple thing in the house. Get a sugar salt solution, mixing sugar, salt, and water. Boil it together. Boil all together. Now, when the water is evaporating, put your hand for the water to condense and taste the water. It's going to be tasting sugar. It's going to be tasting sugar. That's a simple way of crystallization, fractional crystallization. The next one is sublimation. Sublimation is a method used in separating the component of a mixture containing a sublimely volatile solid and a non-subliming impurity. Non-subliming impurity. The impurity there is the liquid. Yeah? Okay. Now, when I say sublime, Sublime is a process whereby a solid changes to gas without passing through a liquid state. That process, that solid, is called sublime, and the process is sublimation. The solid himself is a sublime solid, and the process is sublimation. So it is a process. Sublime is a process or sublimation is a process whereby a solid changes, a solid phase changes to a liquid phase, changes to a gaseous phase without passing through a liquid phase. I'll give you an example. When you open your fridge, the first thing you see is vapor, but nothing is melting inside the fridge. When you allow your fridge to be well frozen, you open the fridge, the first thing you see, vapor comes out. The gaseous state of the solid comes out, okay? But the solid inside, the food inside, is not melting because it did not face atmospheric pressure. Anything that melts has faced atmospheric pressure. So volatile means its ability to evaporate. So in that context, this sublimation is used to separate this thing. Is a sublime volatile solid from a liquid. Okay? When you keep your ice block, the ice block will be evaporating. Okay? As the ice block is evaporating, that particular ice block, that particular evaporation is still the ice block. That particular vapor is still the ice block. But it has changed to a liquid. So if you take that particular vapor in a container, it will be a liquid, and you put it inside the fridge, it will still change back to the solid. Now, when you put camphor inside salt, okay, you mix camphor and salt together. Remember, the camphor does not melt. The camphor only changes to gaseous state. When you throw camphor on the ground, you will not go there and start seeing water. But you see that the camphor is reducing in size. Why? Because it is evaporating. Now, the camphor is a sublime solid. Why? Because it changes to gaseous state without passing through a liquid state, which is melting. Now, if you mix camphor and salt together in your house, you will see that the salt is going to melt, but the camphor will not melt. The salt is going to melt, but the camphor will not. So, if you grind camphor, you pieces camphor, mix it with the salt, okay? It can be separated by sublimation. The camphor will change to liquid, to gaseous state. The camphor will just be evaporating until, after finish evaporating, the salt will remain. That pattern, you have seen that that pattern has been, okay, you can still heat it, okay? When you heat it, you can still heat it, sublimation. Instead, you wait for a long time. You can still heat these particular substances. When you heat these particular substances, the camphor will evaporate and the salt will remain. And that process is called sublimation. The next one is flotation. Flotation is a technique used to separate undissolved solids from liquid. Solids that do not dissolve from liquid. You can still use a method of flotation in that separation. You can still use a method of separation in that separation. You can still use a method of filtration in that separation. So they're almost the same thing. They're almost the same thing, flotation and filtration. Now the next one is centrifugation. So you can see on your screen, it is centrifugating. It's a method used to separate particles from a solution according to their size, shape, viscosity, and density. Now the instrument used for centrifugation is called centrifuge. It's called centrifuge. As you can see on the screen, as it's rotating it, okay, they are being separated into different bottles. As you rotate it, they are being separated into the different bottles. Those bottles are called tubes. Okay, those bottles are called tubes. So as it's rotating the product, okay, they are being separated in their different ways according to their shape, size, viscosity, and their weight, their density, how they occupy volume, how big they are in their shape. Okay, they are being separated as it's rotating this particular centrifuge. Now the last one is fractional distillation. Fractional distillation. It is used in separating a liquid from a mixture of two or more liquids, sorry. It is used in separating a liquid from a mixture of two or more liquids. Now, fractional distillation is the separation technique that is being used in the refineries. Okay, that's what they use in the separation of mixtures. That's what they use in giving us petroleum fractions. That's what they use in giving us petroleum products. Okay, these petroleum products are being processed by fractional distillation. Okay, and these products from crude oil is called petrochemical. Product of crude oil is called petrochemical. Now, as the heat, okay, is being given to the liquid, different fractions are coming out. As the heat is being given to the crude oil, okay, you see different fractions of crude oil coming out based on their boiling point. Based on their boiling point. Don't confuse it with distillation. Distillation says miscible liquids. Miscible liquids. In essence, these liquids are already been processed. So you mix them together. Like I said, ethanol and water. While in fractional distillation, it has not been processed. It is fractional distillation that is processing it already. Now, the crude oil is a mother liquid. Okay? The mixture of two or more. Now, the crude oil is a mother liquid. Now, when this heat is being given to it in a fractionating column, that is where the fractional distillation is being processed. It is called a fractionating column. The column that they use in fractional distillation is called a fractionating column or a fractionating tower. Now, when this crude oil is being placed inside and the heat is being transferred to it, okay, the crude oil now gets heated. Now, as the crude oil is increasing in boiling point, that is how different fractions of crude oil are coming out. That's how different petrochemical products are coming out. Remember, the first one is the gas, the LPG you use. It's about 20 to 40 degrees Celsius. Then the next one is petrol, about 40 degrees Celsius. So, as it's being heated, that's how the products are coming out. Okay? And it is still separated based on their boiling point. As the boiling point of this crude oil is increasing, different fractions of crude oil are coming out. Okay, so in this fractional distillation, that process, fractional distillation, is the process of separating crude oil into crude oil fractions via fractionating column. Via fractionating column. So, like as you're seeing on your screen, you see how the products are being shaken. The particles are being shaken because it is boiling. Okay? Now, when it gets to your turn, you come out. When it gets to your turn, you come out. When it gets to the turn of petrol, it will come out. When it gets to the turn of kerosene, it will come out. Based on when this particular crude hits its boiling point. So we have come to the end of this lesson. But before we leave, like I always say, we'll use the ExamGuide to know or to quantify what we have learned today. Now, let's go to the ExamGuide. We are here in the ExamGuide now. The subject already you know is chemistry. Now, let's go to 2007 and see what 2007 has for us. 2007, question 46. Question 46 says, which of the following method can be used to separate a mixture of miscible liquids with different boiling points? I told you that miscible liquids are mixed that can be mixed together. And I gave you an example of ethanol and water. And I told you that this process can be separated with distillation. Okay, with distillation. I told you how that the ethanol will evaporate and condense into the canonical flask while the water remains in the column. So the answer is distillation. Distillation. Next one is 2009, number 40. Let's see what number 40 holds for us. Number 40 says what? The separation of petroleum fractions depends on the differences in their... I just talked about it now. Okay, and I told you that the products are being separated into fractions based on boiling point. When it gets to your turn, you come out. When it gets to your turn, you come out. When it reaches your boiling point, you come out. Like when it reaches the boiling point of kerosene, kerosene will come out. Reaches the boiling point of petrol, petrol will come out. Reaches the boiling point of diesel, diesel will come out. So now they're asking us that the separation of petroleum fraction depends on the differences in their boiling point. That is the answer. Now, we still have more again. Let's go to question. Let's go to 2009, number 48. 2009, number 48. We've done, let's go to 2009, number 40. 2019, sorry. 2019, number 48. 2019, number 48. Now, which of the following method is not used for the separation of mixtures? We talked about chromatography that forms a film. We talked about crystallization. We talked about distillation. And these are the three things we talked about in separation technique. Okay? If you check very well, we did not talk about electrolysis. We didn't talk about electrolysis. So the answer there is electrolysis. Let's still go again. 2005, question 34. I think that will be the last question for the day. 34. It says, a solid can be obtained from its saturated solution by, I told you filtration is used in the separation of saturated solutions. I told you that. And filtration, I told you about saturated solution. That saturated solution is a solution where the solid do not dissolve in the solution. That's saturated solution. And I told you that filtration is used in this separation. I even showed it to you practically that the sand remained in the filter paper while the liquid went inside the bottle. Why? Because the sand did not dissolve. It becomes an heterogeneous mixture. So filtration can still be used in the separation of heterogeneous mixtures. So in Nagon, filtration is the answer because they say the solid can be obtained from its saturated solution by filtration. And this solid did not dissolve. So the solid remained on the filter paper while the liquid left. So the answer is filtration. Thank you for participating in today's class. You can practice more questions using the ExamGuide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel. Hit the notification bell and share the videos to people that will benefit from it. Bye.